22.3 on page 335 deals with finding the area of a triangle that we use in trigonometry. So whereas traditionally we're used to things like, just find it, obviously the area of the triangle, it'll be half times the base times the height. That's what we've been used to so far. But on this occasion we don't have a height, we don't have a base. Well, if we were to make 9 the base, we certainly don't have the height going from there to vertex C. We don't have that. We do have an angle, but there is a brand new formula we can use to work out the area of a triangle really simply. Put the mic there, and it's as follows. Again, you can find it in your books, and here it goes. We have the area of a triangle is half A times B multiplied by the sine of angle C. So that's a new formula. Let me explain this ABC business. So let's say, for example, this angle represents the C, then the A and the B will be the two sides which span the angle. So for example, 52 is like the C right there, the 9 would be the A, or the 9 could be the B, doesn't matter, and vice in the same way that the 8 could be the B or the A. So we've got two lengths, A and B, or B and A, and we have an angle between it, 52, which we're calling the C. So ABC. But again, don't worry about learning this. That we're giving to you on the front cover of the exam booklet in Unit 3. You just substitute the values and go. So let's just do one really quickly. So area, this is this one here, A I'm going to do, equals a half times 9 times 8 multiplied the sine of angle 52. And of course you can pick this up straight away and with your calculator get an answer. Well, so I've got 9 8s are 72, so I've got 72 times a half, 0.5, times the sine of 52. Bam, that gives me 28.36, 28.4. So that's 28.4 centimetres squares, of course, because the base unit is centimetres. Alright, again, this has been swiveled round. This might look like a base to you, and in fact can be the base. And if we was to draw a dotted line down there, or even a solid yellow line, great, we don't know what the height is, so we can't use half base times height. So if you're confronted by one of these in Unit 3, the chances are you need to use this one and not that one. So same again, area equals half AB sine C. No marks for quoting that, but you will get marks for substituting correctly. A half times 9 times 11, that's like your A and your B, because between the A and the B is the angle we want, multiplied by the sine of C, which is 59. As you can see, letters don't matter. There's no A, B or C anywhere in the diagram. It's L, M's and N's and actual numbers. So we just pump these in. I'm going to say 99 times 0.5, because 11 and 9 is 99, and we're going to multiply it by the sine of 59 degrees. Comes to 42.4 centimetres squares. Okay, that's two of them. We'll do this one here. Maybe do it in yellow. No, leave it as is. Right, we've got here an A, we've got here a B, we've got the angle between them, so that's ready to go. So, straight in, area equals half of 6 times 14 multiplied by the sine of the C, so to speak, and it really is, well, question C. So angle X is going to be 23 degrees. So they pump it all in. So I'm going to say 3 times 14, half of 6 is 3 obviously, multiplied by the sine of 23 degrees. And that gives us 16.4 centimetres squares. Doesn't seem very big, does it? I'm not sure I like that. But anyway, 23 degrees is quite a slim angle, therefore give us a rather pointy, sharp triangle there with not much area in between, I'd say. So it's got to be right. Half times 6 times 14 times the sine of 23. That's it. And that's the introduction. That's question 1. Over the other page we have these two questions, and this is question 3. Nice question. It's a little bit different, but not a lot. We've got here a triangle ABC has an area of 24, so we're given the area this time, so we have 24 centimetres square. Find two possible values for angle B. Well, let's just see what the calculator does. So half times A times B, there's my B so to speak, multiplied by the sine of angle B, so here we go, sine B, that will come to 24. Okay, so we can work out this little bit here. So half of 72 is going to be 36, so I've got 36 sine B equals 24, and the sine of B is clearly going to be 24 over 36, and let's just get that answer there. 24 over 36, that gives me 0.6 recurring, so let's go 0.6666, that'll do. And of course we're now going to shift sign in yellow here, therefore angle B itself is going to be whatever shift sign is. Remember, you'd have to write down shift sign equals, just go from sign B to B itself, and the examiner would know that you've pressed the right buttons when you get the right answer, like I've just got, and I'll make that 41.8 degrees. Lovely. Please note there are two possible values for angle B. You may recall that in the second quadrant, remember this sort of thing? Let's have a look. 0 degrees, 90 degrees, 180 degrees, 270 degrees, that sort of thing. If that's 41.8 degrees, we have another angle here which is going to be 180, take away the 41, so there it is, 180 degrees minus the 41 there, 0.8 that is, and we're going to get we've got ourselves 138.2 degrees, and these are our two answers. Why is 41.8 an acceptable answer, and why is 138.2 also an acceptable answer? Because if you recall that sine is positive in this quadrant and sine is also positive in the second quadrant, alright? So sine and cos are positive here, sine is positive there only. So if an angle has a sine of 0.666666, then it can generate a positive angle here and a positive angle there, both with positive signs rather. So that's it, two possible answers. Right, let's go and do B then. Right, triangle def also has an area of 24, okay, fair enough, centimetres square, and since I've been given the angle and there's no choice in the matter, there will only be one possible answer for length DE. So we can call it A, can't we, or something like that, call it A, and that's be like our B. So let's just try it. Half times A times, that's alright, half times 10 times A equals the sine of 51. That's not right, is it? Let's just rub it out. Made a mistake. Get rid of it quickly. Do it again. So area. So half times 10 times mystery A times the sine of 51 degrees will give us 24. Okay, let's time this up a little bit. So I've got, let's just get A, and let's just do the sine 51 times a half times 10. So that's 5 times sine 51 gives us. So I've got A times 3.8857, that'll do. So basically I've worked out a half times 10, and then I've multiplied that by sine 51. So that leaves me A times whatever that half 10 times sine 51 gave me, which is 3.8857. And that will come to 24 because the area is 24. Simply divide by this, 3.8857, and A is going to be, I'll let you know in a minute, 8ish, 7ish, something like that, divided by 3.8857, and we'll round it off as 6.2 to one decimal place. Alright, so that's what I make that one. Seems okay, doesn't it? So we've got a 10 there, a 6.2 there, and 51 give us an area of 24 centimetres squares. So that's those two questions done. What else have we got on this side? We've got a handsome looking field over here, which I would do. I really like this one. This is question 4. I'm going to be quick, but it's dead easy, isn't it? A farmer has a field that's between 3 roads, so I've got road 1, 2, 3, that's the lengths there. And this must be the hedge or something, I don't know. Sorry, that looks a bit like a hedge, but who cares? Calculate the area of the field. Okay, so check this out. Join from there to there, and I've got a triangle with an angle and 2 lengths, and a triangle with another angle with 2 different lengths. Essentially, I've got to work out the area of this triangle and that triangle and add up the 2 bits, and that's really, really easy. So let's just do it quickly now. So here we go. Area coming up. So I'm going to have total, I'm going to do it in one step. This is grade A, we can do it. So total area is going to be the 2 bits. Half times 95 times 110 times the sine of 77, that's 1 bit, plus half of the other bits, 90 times 65 times the sine, doesn't need the bracket really, times the sine of 112 degrees, and I'm going to do that in one go. So that's this triangle here, and that's this triangle here. Add up the 2 bits and my calculator can handle it. So here I go. 0.5 times 95 times 110 times the sine of 77. Then I'm going to go plus 0.5 times 90 times 65 times the sine of 112 equals, and it's giving me an answer of, oh, quite big really, not surprising, it's 7803.09, yeah, go 0.1 meters squared. Does that seem reasonable? Well, if this was a rectangle alone, it'll be about 110 times 95, roughly 100 times 100, 10,000. So we're in the right sort of Right then, a lovely question 5 coming up. It says an equilateral triangle and a square have the same area. So equilateral triangle, let's just draw us so you can see what we're doing. Equilateral triangle, doink, and a square that also goes doink and looks an awful lot like a rectangle to me. It's got issues. Right, that's that. So equilateral triangle and a square have the same area. So equal area. So area of equilateral triangle equals area of square. Now the square has a perimeter of 20 centimeters. So if it's 20 centimeters, like I've already written a 5 there from before, so I've got a 5 by 5 and 5 all the way around, that's 20 centimeters of perimeter. So the area of the square is going to be 5 times 5, 25 centimeters squares of area, which means the triangle also has an area of 25 centimeters squares. Our job is to find the perimeter of the triangle, which means we better work out one of these sides first. So I don't know, we'll call this x, we'll call this x, we'll call this x. If I know what one of the x's are, multiply by 3 and we're home and dry. Now, equilateral triangle, that means each of these angles are 60 degrees, and I've got a very simple relationship involving sides, angles and areas in a triangle. So do you recall that the area of a triangle is half AB sine C? Always look at the front cover of your exam paper of Unit 3. So half AB sine C, let's substitute what we know. Half is, well, half times A, don't know what that is, that's like x, times B, well, that's x as well, times the sine of 60 will come to 25. Alright, so we're playing with 25. Let's tie this up a bit. I've got half times sine 60, it's going to be as follows. So sin 60 equals, and divided by 2, that gives me 0.433. So I've got 0.433 times x squared, that's those two, all comes to 25. So x squared on its own is going to be 25 divided by 0.433. Put the answer there. And I've got here 57.736. I'll stop there. So x is going to be the square root of that, 57.736, and let's just root it on my calculator, and I've got 7.598. So that's just one of the lengths. So that is 7.598. Of course I won't leave it like that. This is multiplied by 3. Put it here, I suppose. The perimeter is going to be 3 lots of 7.598, and that's going to be 22.795. Yeah, 22.8 centimeters, and that's it. Lovely, isn't it? So that's a really creative question. So what we've got here, we've got seemingly a question with just one number in it, a simple number 20. We got all this out of it, and we got the perimeter of the triangle, 22.8. Beautiful. All right, see you later in the assess.